Good morning, everybody. My name is Percy Foster from Cray. I'd like to welcome you all here this morning to our meeting today to talk about the Biopost project. We have good attendance today, and hopefully everybody is able to hear me okay, and that everything will work out. Biopost is a new project. It's a research project which is looking at on compostables, and Ramesh will explain to everybody how this project will work. The project is led by Trinity College Dublin, University College Dublin, and by Cray, and has been kindly funded by the Irish government under the Environmental Protection Agency and the Department of Agriculture, Food and Marine. Today, we will have three speakers. We will have Professor Ramesh Babu from Trinity College Dublin will explain the Biopost project. We have Oliver Lamberts from TOMRA who will talk about techniques and how to separate compostables from conventional plastics and technologies that are developing in this area. And then finally, Paul McDonald from Department of Environment, Climate and Communications will talk about the new waste policy. After that, we will have Q&A for all the speakers. So during the event, if you have any questions, please place them in the Q&A function at the bottom of your screen. After the session with the three speakers, we will then break out into rooms to have a breakout session where we're going to talk about three topics. And when we get to that stage of the meeting, I'll explain how that works. So let's get started. And our first speaker is Professor Ramesh Babu from Trinity College Dublin, who is going to explain the Biopost project.
Trinity College
Lindsay,
Dublin.
can you hear this?
Welcome to Biopost Stakeholders Workshop. This morning, I'm going to
can hear it.
Our project
Biopost,
looking at developing sustainable, biodegradable, compostable, and recyclable plastics for packaging applications, and also understanding the end-of-life management of those products. This project is funded by EPA Ireland and Department of Agriculture, Food and Marine. This project is coordinated by me along with Professor Kevin O'Connor from UCD and Percy Foster and Conan Burton from Composting and Anaerobic Digestion Association Ireland. As we all know, plastics are an integral part of our modern life. They are great materials given their properties such as durability, lightweight, and cost. They contribute a lot to our economy. However, the single-use throwaway culture and how we manage after use creating any huge environmental issues. Nowadays, managing a plastic waste is an agenda for most of the governments and remains a critical issue around the globe. Here is the statistics of plastic waste generated in Ireland and how it is managed since 2001. As you can see, in 2016, the total plastic waste generated is around 260,000 tons. However, the recent statistics shows the amount of plastic waste generated is increasing, and currently it is more than 300,000 tons per year. In terms of recycling, around 36% of plastic waste is recycled, and 90% of which is exported to other countries. This scenario was before the export ban on plastic waste. Also, Ireland is the highest per capita waste generated in EU compared to other countries. In order to reduce this waste, a number of key measures was put in place by our government. Recently, we have banned use of single-use plastics, and also we have ambitious plans set out in our climate action plan, like 90% collection of plastic drink containers by 2029, and also ensure all plastic packaging is reusable or recyclable by 2030. If you look at current scenarios of plastic waste, nationally concerns are growing over increased plastic waste and also how the managing of this plastic waste. As per current statistics, there is a 6% of increase in plastic waste every year. This is mainly due to attitude, make it, use it, and discard it, and also single use and linearity of current plastic products. Since 2018, we have a ban on exporting plastic waste to China. So there is a huge amount of plastic waste piling up in the country. Locally, we don't have any or little infrastructure to deal with that amount of plastic waste. No Irish recycling facility is equipped to deal with such significant levels of plastic waste for recycling. Landfilling could be an option. However, our landfilling capacities are reaching nearly zero. Suppose if you look at 10 years ago, we have nearly 120 active landfilling sites in the country. However, currently they're down to 2 to 3 sites. Also, as per new EU directive, we have ambitious targets of reaching recycling 60% by 2030. In order to reach this, we need to double the volume of current recycled plastics to achieve those targets. So to overcome these problems, we really need a transition to more circular and sustainable materials so that we can minimize the waste by keeping the materials in loop as long as possible with minimum carbon footprint. So the biodegradable plastics is a choice. There are a number of advantages with the biodegradable polymers. Since these materials are degradable in multiple environments under managed conditions, so they are less pollution. And this is not possible with fossil-based plastics. Secondly, the amount of fuel consumption associated with greenhouse gas emissions are much lower compared to fossil-based polymers production. For production of these polymers, we don't need to use fossil fuel directly, but some of the associated processors still use fossil fuel like a transportation energy to produce these biodegradable polymers. And other thing is the biodegradable plastics have a better end-of-life options compared to fossil-based plastics. For example, biodegradable plastics can degrade in industrial composting conditions, and this is not possible with fossil-based plastics. As we all know, there is a huge push from EU to promote and commercialize biodegradable polymers through legislation and also funding a big commercial programs like bio-based industries joint undertaking programs. This is one of the recent study published on greenhouse gas emissions associated with the production of various fossil-based plastics, converting them into products and end of life of those products. As you can see on the outer circle, shows the amount of greenhouse gas produced for various types of individual fossil-based polymers. The inner circle shows the total amount of greenhouse gas emissions associated with production of polymers, converting them into a product and their disposal. It is interesting to see in the green, actually the greenhouse gas emissions associated with the landfill is minimal. But as you all know, this is not a real option because we don't have a land to put them into. Overall, the greenhouse gas emissions from fossil-based plastics alone corresponds to 3.8% of total global greenhouse gas emissions. This same study actually looked into greenhouse gas emissions for plastics produced from fossil-based resources and also polymers produced from first and second generation biomass. As you can see, the greenhouse gas emissions associated with the production of 1 kg of fossil-based plastic is around 3 kg of carbon dioxide, whereas in case of bio-based products or biodegradable plastics, it is around 2 kg of CO2 for production of 1 kg of the polymer. So the most of these greenhouse gas emissions are coming from the source of energy used for the production of these plastic materials. In case if we move all the energy sources to renewable energy like a wind, solar for production of these polymers, the greenhouse gas emissions can be reduced by 50 to 60% for all types of polymers, including biodegradable polymers. Also, we looked into scientific literature to understand the greenhouse gas emissions for both fossil-based and biodegradable polymers. On the left-hand side bar chart, you can see the greenhouse gas emissions are much more lower for biodegradable polymers like PHA and PLA compared to some of the fossil-based polymers like PET. On the right-hand side, similar trend is observed in terms of fossil fuel consumption to produce these polymers. Definitely for producing polymers like PLA and PHA, the fossil fuel consumption are much more lower compared to polymers like a PET or HDPE or polycarbonate. If we look at the current end-of-life options for most of the plastics, mechanical recycling, landfill, and incineration are widely adopted options. This can be useful for both fossil-based and biodegradable plastics. However, in the case of biodegradable plastics, industrial composting and anaerobic digestion can be adopted, whereas this cannot be adopted for fossil-based polymers. So this can broaden the range of waste management options for biodegradable plastics. And also it will give a possibility to recycle and reuse the carbon source. There are other end-of-life options being evaluated and developed at the moment, such as chemical recycling and biological recycling, which can be adopted for both fossil-based and bio-based plastics. Also, the recent EU Green Deal highlight the importance of bioplastics for circularity and decarbonization. As you know, they can reduce our dependency on fossil-based resources and also reduce the greenhouse gas emissions. Also, by recycling the biodegradable plastics, we can reduce the footprint of plastic waste in our environment. If we look at the commercial side of these biodegradable polymers, currently they're relatively expensive compared to a lot of fossil-based polymers. However, we anticipate that these prices will come down as converters and end users adopt products based on these biodegradable polymers. As we all know, the cost for fossil-based polymers tend to change based on crude oil prices. So by taking all these advantages of biodegradable plastics, Biopost aims to develop biodegradable composites suitable for packaging applications and develop an ecosystem for biodegradable plastic products by evaluating various end-of-life options. Also, to provide any clear guidance on end-of-life options for biodegradable products for a policy development. However, there are a number of challenges to be addressed to adopt these materials. Most of the biodegradable plastics does not meet the properties of fossil-based plastics to just replace them for various applications. Secondly, the separation of these biodegradable plastics from mixed plastic waste is a challenge. Currently, the amount of biodegradable plastic products in the plastic waste streams is really small. Also, the recyclability of these products is not well established. So it is important to understand uh, the biodegradability and environmental impacts under local conditions is essential to create an ecosystem for these products. In order to address all these challenges, Biopost is bringing together important stakeholders from research end, Trinity and UCD, and recycling companies like Aponta, composting and anaerobic digestion companies represented by CRAE, and policy end represented by EPA and DAFM. Biopost has 6 main tasks with a number of objectives as a part of this project. The first 2 tasks are mainly focused on developing biodegradable composites based on commercial biodegradable polymers. Also, we use proprietary biodegradable polymers to improve the properties of the commercial composites suitable for packaging applications. These composites will be characterized for their mechanical, thermal, and especially for barrier properties, which is required for most of the packaging applications. The best performing composites will be scaled up and produced on a pilot scale to create a prototype packaging films. And using these prototypes and other commercial plastic products, we will create a plastic waste mix and study the separability of biodegradable products from the mixed plastic waste under industrial environment. Once we recover these products, actually, we want to analyze them and reprocess them to see the reusability of these recovered biodegradable products. Towards the end of this project, we will evaluate the biodegradation of the composites under industrial composting and anaerobic digestion conditions to understand the biodegradability of these composites And also we'll perform life cycle analysis to understand the environmental impacts of these composites developed. So towards the end of the project, these are the main deliverables we are expecting from Biopost project, mainly the biodegradable polymer composites and blends, which are suitable for packaging applications, and also material data sheets for optimized formulations, report on separation and recyclability of biodegradable plastics, and then a white paper on life cycle analysis and biodegradability of Biopost composites. To find more information about the project, please visit our website, biopost.ie, and also follow our Twitter account, Biopost Research. Thank you very much, and looking forward for your valuable inputs. Thank you.
Thank you, Ramesh. And as I said at the start, if you have any questions for Ramesh, please type them into the Q&A button at the bottom of your screen. So our next speaker is Oliver Lamberts from TOMRA. And Oliver, thank you for joining us here today.
My name is Oliver Lamberts. I'm responsible for business development at TOMRA.
Kevin, can you hear the sound?
And I'm very pleased to be here. And thank you very much for the invitation to speak on your conference. I have recorded this presentation, though, so please don't be surprised if you will see me in a different shirt and probably a bit better shaved in your Q&A session later on. Yeah, let's dive right into the topic. This is the content of my presentation. I will show a few slides about TOMRA, what we're doing, and then we will go right into the topic of today about biodegradable plastic. And here I would like to focus on the status, what kind of technologies are available today and might be available in the future, what are challenges in general with sorting of biodegradable plastic and opportunities, all from a waste management perspective. So, and I'm really interested to hear the other presentations in order to learn more about your industry. TOMRA is a stock-listed company based in Norway. We have more than 4,000 employees and two main business areas, which is the collection solutions, what you can see on the right-hand side here. That's like I would call it the traditional TOMRA business. Here we provide reverse vending machines, for instance, for retailers. Those of you that are familiar with deposit markets, for instance, for PET bottles or aluminum cans or glass. That's the unit where you can return your bottles and then you get your deposit back. On the left-hand side, equal size of business approximately today. Our sorting solutions here, we provide central-based sorting solutions for different industries. Main industries are the food production industry, recycling, that's where I'm based, so waste management and recycling, and then the mining industry. Last year we established in addition our new circular economy division. This is a cross-functional division over different company business areas, and here we focus really on holistic solutions, on today mainly on plastic recycling, because that's where we see the main challenges today. This is an overview of our sensor portfolio. You can see we use a lot of different sensors in our equipment. Most commonly used is the near infrared. I will go a bit deeper into that in later slides. But we also have lasers, we have X-ray technology, we use like color cameras. You see it here, electromagnetic sensors that we can then also combine for different applications and tasks. How does a sensor-based sorting unit work? I suppose most of you are probably familiar or have seen equipment somewhere. We have also a lot of installations in Ireland that use our technology. But yeah, there are basically two main, I would call it mechanical setups that you can find. On the left-hand side, you see a typical belt sorter. You have like the unsorted material, which is fed to a so-called high-speed conveyor that runs with like about 3 to 4 meters per second. Then we have like the scanner, that I would call it that intelligent eye on top of the belt that reads the material, determines the position, material type, color, and then we can eject the target material with air jets into different fractions. On the right hand side, that's what we call a chute sorting system that's, for instance, applied a lot in the plastic recycling industry, for instance in PET. Then it's mainly known as a flake sorter, so that's used to remove final contaminations from plastic flakes. And yeah, typically in that case then of course addressing very small objects and particles. Then I mentioned near-infrared technology. That's the most commonly used technology to separate plastics, for instance, by plastic type today. Here we look in a wavelength area of between 1100 and 1900 nanometer. You see as well where the visual light is located. That's what we use with our human eye to see different colors. And yeah, what is important about near-infrared? So different plastic types have different reflection and absorption of near-infrared light in different wavelength areas, and that's actually exactly what we use to distinguish and sort them by material type. You see on the graph on the right hand side 2 different materials that have like different peaks, for instance, in different areas, and then when we look into these specific areas, we can really make sure that we are able to separate that into monofraction. So you can say every plastic has a kind of fingerprint, and that's what's used in the separation. Here we have one example of a sorting facility. I just picked one example of a big plant in Sweden, which is sorting packaging waste. Optical separators are then one part of the total plant. We have a lot of other equipment, mechanical equipment, from shredders, bag openers, over screens, wind shifters, ballistic separators, and then typically after like initial mechanical treatment, you apply then optical separators to recover different material types. Every orange box that you can see here is one optical sorter that sorts one dedicated product. And you see here a list of typical fractions that are recovered. Most commonly, these are like standard polymers, and we could come back to that topic a bit later. Let's have a quick outlook into our activities on the plastic recycling. So today, with exception from PET, where we have some bottle-to-bottle recycling, you can say that like the concept that you see on the top now in the graph is the most common way of treating plastic today. So you have like pre-sorted plastic bales, HDPE, PP, could be polystyrene, that go to a recycling plant. Here the plastics are shredded down to a flake level. Typically you have a cold washing process, simple mechanical separation process, and that washing and recycling process, and then it's finally an extrusion step, and you get typically some kind of thick wall products. Our ambitions and activities in the last 7-8 years have looked very much into high quality recycling, mechanical, we call it mechanical closed loop recycling, also for other polymers, so not only on PET. So that means the complex or the process at the recycling stage is a bit more sophisticated than the traditional process. So we apply additional color and material sorting. We apply grinding and hot washing. That's not in our scope of supply, but we work with partners on that. And then finally, it also includes like flake sorting, extrusion, and deodorization steps. So finally, the target is to really close the loop. So that just, and now finally, let's have a look into the biodegradable plastic. I just would like to show as an introduction different spectra of different polymers, and I selected two known biodegradable plastic, TPS and PLA. So it's the blue, one blue and one orange curve here, and then in comparison to that some spectra of standard polymers such as PET, polyethylene or polypropylene. And as you can see, like the more different these curves look, the more easy it is to distinguish these type of plastic with near infrared. The feedback from the slide is yes, you can actually also separate PLA and or TPS in monofraction, similar like we do for standard polymers today. So that's the statement I already made, but one addition, sometimes it's difficult, at least for human beings, to distinguish biodegradable plastic. So if you apply manual picking, which is still in place in some areas, then that might be really challenging for people to distinguish then different type of plastic. And I think this is also, at least one from my point of view, one relevant question for consumers, because if you're considering to collect biodegradable plastic in a composting bin, you need to make sure that consumers are able to distinguish these from conventional non-biodegradable plastic. So labeling for sure will be an important topic. So basically, technology is available today to sort biodegradable plastic, and if needed, also by polymer type. But, and that I would say is the main challenge today, the individual and also total amount of biodegradable plastic today in the waste streams that are sorted is very low. So from an economical point of view, this is very challenging for us to sell any unit if the amount of the material that we want to recover is that low. And another point, and that's more like the perspective then from a waste, from a MRF. If you recover HDPE, PP, PET from a plant for mechanical recycling, you're able to sell such a bale for what, let's say 150 to 250 euro per ton, depending on the quality. If you would do so for a biodegradable plastic and send it to a composting process, typically and it would be great if I'm mistaken, but typically you have to pay for it. So one question from my side, would it be not interesting to look also into mechanical recycling of biodegradable plastic? And then at the same time we would need to answer questions, are these conditions, 85% hot water degrees hot water, caustic soda, are these feasible also for biodegradable plastic? Of course there are, and that's what I would say what might be an opportunity, economical advantages for using biodegradable plastic. If you can avoid green dot fees, recycling taxes, and so on. So I'm really curious to hear probably your points on that. But yeah, that's just a few statements from my side or from our industry. As it was mentioned initially, I also would like to show a little bit about new technologies that are in development. Digital watermarks, that's a technology that aims to go beyond today's limit of near infrared technology, as I mentioned initially, to sort PLA or TPS. Today, near-infrared can easily do the job, but here, for instance, we are also looking into to distinguish food from non-food plastic. That's something which is not possible just with near-infrared. We worked on this Holy Grail project since a couple of years. We did the proof of concept. We arranged some open house events at TOMRA, and we are also member in the follow-up project Holy Grail 2.0. And here the aim is a future development of new prototype for industrial application. So this is actually what I wanted to show. I hope I managed to be in the time. It looks good if I look on the timer, so I'm very happy to take questions later on. Thank you very much. Hello.
Sorry, folks, just give me 1 second. Thanks, Oliver, for that interesting presentations, and apologies, folks. I'm used to working in the webinar format of Zoom, and this is a meeting format. I know that the Q&A button is not above your screen, so when we get to Q&A, I'll ask you to raise your hand and you can ask your question verbally. So I'll just ask our next speaker, Paul, if you could turn on your screen and your microphone, please.
Yep.
Paul. And Paul, you should have the function now to share your screen and your PowerPoint presentation.
Okay, good morning, folks. Paul McDonald, as you can see there, I'm principal in the Circular Economy, Waste Policy and Natural Resources division within the Department of Environment, Communications and Climate Action. I'm going to talk a little bit about the Waste Action Plan that was launched back in early September of this year. Just by way of a little bit of background, just the policy context and development. It's the policy that it replaced was called the Resource Opportunity, which covered the period of 2012 to 2020. It's obviously interacts with the Climate Action Plan and the commitments in there. Some of the external issues around it are the EU Circular Economy Plan, the European Green Deal, and obviously the UN Sustainable Development Goals. This is some of the background impacts that we were taking into account. The program for government, as you know, the program for government was put together earlier this year with the new formation of government. There's a strong emphasis, obviously, in there on climate and some specific waste action points, which I'll come to later on. The program, or the waste action plan, was put together. There was a strong emphasis on stakeholder engagement, and we sort of kicked off with this with a launch back in September 2019 with a stakeholder forum that was chaired by the Minister Bruton at the time. So out of that, we had a lot of workshops which looked at specific items or specific topics. We took them back and issued a consultation document then in December 2019, which was open until February 2020. With a very, very healthy reaction to that, over 280 submissions. We then established what we call the Waste Advisory Group. So this was a group put together, and again, I think some of you looking at the participation list here today, I think quite a few of you would have been at those meetings. Obviously, when the COVID-19 restrictions came in, we went online. I think we had a total of 8 meetings of that group, which looked at specific topics of discussion and debate. One around plastics, which is obviously a key issue here, the deposit return scheme, citizen engagement, and a whole host of issues. So the plan, which I don't know if many of you have read it, there's about 21 sort of chapters within it. We try to break it down into sort of bite-sized chunks, looking at specific items of the circular economy, the municipal waste, empowering households, food waste, plastic, single-use, byproducts, EPR schemes, a whole range of topics. So what we're saying is that we want to think of it as an action-focused plan that would place Ireland at the vanguard of EU performance. It's I suppose, you know, a lofty claim, but it's I think we have to be ambitious in what we're trying to achieve here. It's a range of more than 200 short, medium, and long-term actions. Some can be implemented immediately, others require supporting legislation, both primary and secondary. Again, as a lot of you will be familiar with, there's a range of issues at EU level which are currently in train around single-use plastics, around the various producer responsibility schemes. So we'll be monitoring progress there, and we're also trying to put together a new circular economy bill for sometime next year. Now, what we're saying is that this is a marathon. It's not a sprint. It's a 5-year plan. The previous plan went, you know, for quite a number of years. So we're looking for this as a 5-year plan. We have the Waste Action Group, which I referred to earlier on, has now taken over an implementation role. So we'll be looking to continue this high level of engagement with the various stakeholders over the course of the plan. So the overarching objectives of the plan are, I suppose, like we've some of it has been referred to earlier on. The way, I suppose, waste policy operated up to now was sort of make, use, and discard, or, you know, take and make and discard. Now we're looking to embrace this circular approach as opposed to the linear approach. So we're trying to shift the focus away from waste disposal to ensure that materials and products remain in productive use for longer, thereby preventing waste and supporting reuse through a policy framework that discourages the wasting of resources and rewards circularity. Clearly, all of what the things that we're trying to do here is to say, as it's a marathon, would be to try and introduce behavioural change and support behavioural change. And this is, you know, obviously that's something that applies across the board on the issues related to the climate action plan and so on, that we're trying to foster a change in behavior. So at user end, while looking at further back on the scale. So we'll be looking to make producers and manufacture and sell disposable goods accountable for what they place on the market, and try and ensure that we support sustainable economic models and support clear and robust institutional arrangements for the waste sector, including through a strengthened role for the local authorities. Just to look at some of the headline actions of the plan. Attainment as conditions of permit. This is for waste collectors. Will have to include a target as a condition of getting a waste collection permit. A deposit and return scheme. Some of you who are familiar with this may have seen that we went out about a month or so ago on a consultation paper around a deposit and return scheme. The DRS schemes was referred to specifically in the programme for government, that we would introduce one of these. So we've started that process of the consultation period closed just over a week or so ago. And again, we had close enough to 400 responses to that. I think the overall reaction was very positive from the general public. And we're currently working our way through some of the details of some of the submissions on that. We'll be obviously looking at economic instruments with either, of course, of levies. We've heard discussions around, you know, so-called latte levies and so on. We'll be looking for an eventual ban on disposable coffee cups. So the Waste Action Plan that we launched in September is a precursor to a whole of government circular economy strategy. Now, there has been, again, I know some of you will have dealt with the department over the last number of years, but there has been an investment by the department in increasing the capacity of the waste area Previously, there would have been one principal officer in the area. There are now three. Kevin O'Donoghue, who some of you may know, myself, and Les Carberry. Kevin will be continuing to look after issues such as capacity, enforcement, and collection. I'll be looking after policies around plastics and EPR schemes and landfill remediation. And Leslie will be taking on the circular economy strategy, as I say, moving to a whole of government circular economy strategy. So we just set out some of the headline actions there: the deposit and return scheme for plastic bottles and cans, high level of government circular economy strategy, and new rules for EPR schemes to incentivize good practice in waste cycling and driving better product design. Again, all of these issues, we're trying to relate them into a whole of government circular economy action plan, as opposed to simply waste management. Again, just to look at some of the headline targets for household and businesses: recycling targets for waste collectors, standardizing bins and a waste recovery level, and an education and awareness campaign. It's been touched on in some of the earlier speakers. I mean, clearly a huge issue around waste management is this question of segregation. And if you look at the current regimes, you've got different color schemes for bins and so on. Some areas have these food waste bins, the organic disposal bins, others don't. So we're trying to get a sort of consistency of approach across there. So there'll be a lot of work on that. Food waste, again, when some of you may have been familiar, when the action plan was launched, there was a lot of discussion around food waste, and some elements of this, or there was some articles in the press suggesting that what we were trying to do was to attack the issue, such as 2-for-1 offers and so on. And that's clearly not where we're coming from. The big picture here is to try to halve our food waste, introduce more sustainable food waste management options for both houses and businesses. And again, this issue of a waste segregation infrastructure for in particular, apartment dwellers. And again, for what we're talking a lot about today, plastic packaging and single-use plastics. The deposit and return scheme, which I've mentioned, the single-use plastics ban. As a lot of you will know, the single-use plastics directive currently being refined and finalized at EU Commission stage levels. But there are some things that we know what happens. It'll come in July of next year. So it will introduce a ban on certain issues, or on certain items, cotton bud sticks, cutleries, and so on. And the overall trend is to try and reduce the number of single-use plastics being placed on the market by 2026. We have some, quite difficult targets around single-use plastics to meet for 2025 and 2030. This is part of the rationale or the motivation behind introducing the DRS, the deposit return scheme. Just moving on to look at some of the other headline items: EPR schemes, the various producer responsibility schemes. These are currently in existence, as many of you will know, for certain items like electronics, tires, and so on. So we'll be looking to extend those and make EPR mandatory for all packaging producers before the 2024 deadline. And making producers liable for eco-modulation. And what we mean by eco-modulation is that the packaging products that are placed on the market, with those which have a higher degree of difficulty for recycling, will face a higher level of fees as they are placed on the market. So the idea is to encourage more eco-friendly and recyclable packaging products coming on the market, and the intention to have all packaging reusable or recyclable by 2030. Again, some of the other headlines: the C&D, the construction and demolition waste. Obviously, as please God, as the lockdown eases and the economy kicks in, and if the construction industry is kicked off again, I know it has continued. We'll be looking to make some of the streamline some of the byproducts and notification and end of waste issues arising from the C&D sector. And we'll be setting up a working group to develop national end of waste applications for priority waste streams. Another area that got quite a lot of attention at the launch was this question of textiles. Fast fashion is what it was referred to. And again, there was some confusion as to whether we were trying to target lower priced products coming on the market, and that clearly is not the intention. We will be setting up a textile action group to explore the options for future circularity in textiles, working with designers and retailers to promote eco-design. Again, going back to this whole notion of circularity, if you improve such things as the eco-design, make it easier for reuse and repair and so on. These are some of the issues we'll be looking at specifically into textiles. Some final issues to look at: the treatments, how we'll be reviewing the support for the development of recycling infrastructure, examining legislation and procedures for development of waste management infrastructure. There's quite a bit of work has been gone on even since the launch of the report back in September. Some things are some ideas that have been put forward, and certainly we'll be looking at them. I don't want to go into too many of them at this stage because it's quite early days, but this idea of having a homegrown recycling infrastructure is something that we're very keen to examine and see what we can do in it. Enforcement is something that we were always trying to improve. Any waste policy or waste management program must have a robust enforcement model to accompany it. We've done a lot of work on that over the years by the establishing of the wireless, the regional enforcement groups. So we'll be looking at trying to come up with an action plan for unauthorized sites and an anti-dumping toolkit, and fixed penalty notices for breach of waste law. So this is one of the areas that we'll be looking to, which will require some primary legislation on that. Government leadership on circular economy. I've touched on this earlier on, that we'll be looking for an all of government circular economy strategy, inclusion of green criteria and a circular economy, develop circular economy sectoral roadmaps, and explore how the digital sector can accelerate the transition to a circular economy. Just our department has also, as well as having the waste and environmental and climate action, also has the brief around the digital sector. And one of the areas that has just recently come to the fore on this, I touched on earlier, the deposit return scheme. And there's been quite a number of the submissions on that consultation paper have referred to sort of smart collection policies around collection of PET and aluminium cans. This idea of using technologies of apps and QR codes and something. So it's something that we'll certainly be keen to look at in the course of the implementation. So that's essentially it. What say we've come quite a fair bit over the last number of years. We've made quite a bit of progress. We're keen to maintain that momentum, and this is what we have set out to achieve in the Waste Action Plan. We're now on to the implementation phase. I suppose, as has been said before, plans and action plans are often written in poetry, whereas the implementation phase is very much written in prose. So we've a lot of work ahead. One key part of this is this question of education and awareness, which is key to what we try to do on what we call the waste management side, but in particular around the circular economy as we try and instigate a level of behavior change. We'll be trying to use a lot of the normal platforms and social media and so on. So a lot of this stuff, if any of you are familiar with the mywaste.ie portal, which is run by our partners in the regions, where we'll be using that as a key communication tool over the course of the implementation period. That's essentially it. A quick run through there of the Waste Action Plan. Thank you.